The ground we stand on accounts for only 30% of the Earth's surface. So what about the rest? Well, that other 70% is our world ocean, which to many of us land dwellers may seem like a foreign concept. An intangible body of water largely separated from our day-to-day lives. But in reality, the ocean is the one common link that connects us all. The food we eat, the air we breathe, the storms we ride, and the economies we build are all dependent on our world ocean. On this podcast, we will dive into emerging markets, innovative technology, and conservation efforts to shed light on the ocean, the other 70%, that enables us to have a footprint, a home, and a life on Earth. The other 70% is brought to you by Nortec. As ocean enthusiasts, researchers, and technologists, we are on a mission to make an impact through innovation, exploration, and activism above and below the surface. Help keep us exploring by subscribing on your podcast platform of choice. Hello to everyone out there listening, and welcome back to this week's episode of The Other 70%. I'm your host, Nevin DeParlo, and today we will be hearing from the man behind Kelly Slater's Perfect Wave, CTO of KS Wave Co, Adam Fincham. When world champion surfer Kelly Slater dreamed up the idea of creating the perfect wave in a man-made pool, the passion project led him to Fincham, a professor at the University of Southern California. While Fincham was not an avid surfer, and in fact had never heard of Kelly Slater at the time, years of research in turbulence and fluid dynamics prepared Fincham to take on the engineering feat of a lifetime. Nearly a decade after Slater's initial proposition, the perfect wave was born into existence at the so-called Surf Ranch in Lemoore, California. In this episode, Fincham talks about his varied and impressive road in academia that led him to connecting with Slater, the process of bringing the wave from dream to reality, and how the wave pool could fit into the sport of surfing in the future. Without further ado, let's dive into today's episode with Adam. Well, Adam, welcome to The Other 70%. It's great to have you on.
Well, thanks for having me, Nevin, and it's a pleasure to be here. So it's probably going to be a lot of fun.
We're looking forward to it, and this will be a good time. I guess to start things off, Adam, I just want to get a little bit of background on you and how you ultimately ended up getting involved in wave pool design. Was surfing always a part of your life, or was it something that just sort of came into your life later on from a more technological standpoint, an opportunity to develop something pretty cool with the wave pool side of things?
Yeah, that's an interesting aspect there. I never really surfed on a surfboard until college when I came to California. But prior to that, I had been quite an avid skateboarder. So I was interested in board sports, I could say. It was interesting to me. Maybe looked at some surfer magazines back in the day because there used to be a crossover between surfing and skateboarding back in the 70s. It was sort of a kind of went together. Back in Jamaica, we didn't really have any active surfing. There were some waves in some little areas, and there was a small little group of people who might have gone out and surfed every now and again. But definitely through skateboarding, I was interested in surfing. Coming to California, it was a big thing. Surfing was all around, and some point in college there, I got a board from somebody and a wetsuit because it's kind of cold, and gave it a go a few times. Went out with one of my colleagues, Jeffrey Spedding, and he took me out a few times in Malibu. And I was naturally okay at it because I knew how to balance on the board, and I was kind of young and sufficiently athletic and a good swimmer. I've always been a very strong swimmer. Grew up in the ocean in boats and stuff. So I was interested in it, but it never was something where I would have ever called myself a surfer. Certainly not. A surfer is someone who gets up at 5 a.m. and goes out every day when they sweat. That was not me. I'd be, what do you call it? The weekend surfer, occasionally go out, every now and again.
The weekend warrior.
Yeah, it would just be like that.
There you go. No, that's great. I mean, I think everyone who has an affinity for the water sort of has different stories of how they first got in. So I think that's interesting. I mean, personally, I grew up in Vermont. I was a skateboarder, snowboarder, and ultimately got into surfing and kiteboarding and everything as well. And so it's funny how all those board sports worlds collide. And then for you, it really collided, I guess, because in college you were also, what were you studying at the time? And you were.
I was in aerospace engineering department.
Okay.
So mainly working on turbulent flows, turbulent boundary layers, then later on. So a lot of that was wind tunnel work in the beginning.
Yeah.
In the beginning, it was hot wire probes inside of wind tunnels and things like that. A little bit of computing work back in the day. In fact, when I was 1985, we were still using reel-to-reel tapes on PDP 1155 computers, that you program without a keyboard. You had all these buttons and you had to know which order to press them to boot the machine and load your program off of giant, 12-inch diameter tapes. So it was a lot of exposure to computing and automation and data acquisition, which was mainly when I moved from wind tunnels into water. We had a water channel at the university there. And so the water channel was akin to a wind tunnel. It was a recirculating channel. And we also had the ability in the test section to add a towing device. So you could have a towing object also in a background flow. And it was a low turbulence facility, again, looking at boundary layers, turbulence, and things like that.
So I guess to backtrack, you were growing up in Jamaica, you were skateboarding, you came to California for school, you're sort of studying aerospace engineering and started to surf a little bit. You transitioned into, I guess, the water-based physics portion of your studies. And where did it sort of go from there? I mean, in terms of how it then transitioned from, you were studying aerospace engineering, you started to work in more of a hydrodynamics space.
Right.
Where did it sort of go from there? What was the next part of the transition?
It was still on turbulence at that point. And I think the transition came when I moved from looking at turbulent boundary layers, which were done, either in the wind tunnel or in the water channel, to work with my mentor, Tony Maxworthy, the late Tony Maxworthy, who was in geophysical fluid dynamics. So he was sort of more into stratified and rotating flows that mimic the ocean and the atmosphere or other planetary flows. And he had another laboratory deep down in the basement where he had a large tank, which was set up to model what some people at the time called two-dimensional turbulence through the aid of salt stratification. So I decided that seemed pretty cool to work in that world. And in what we called the GFD lab back then, we had other students and postdocs working on, we had a rotating tank, we had several rotating tanks that, you get the Coriolis force. So now you're really simulating vortices that you might find in the ocean and the atmosphere. And we had several projects going on there. And it was an interesting group of people who worked there that kind of stimulated my interest more in, rather than working on just on turbulence for engineering applications. It was more interesting to work on turbulence as it related to nature and the geophysical environment that we live in. And so that was sort of a transition there from more engineering applications to more what I call natural applications of understanding the planetary flows.
So I guess time frame wise, that's when was that you sort of started?
Well, that would have been in 1990 when I made that transition.
Okay. And then, so since then, I mean, obviously it then took a number of years before you got involved on the wave pool side of things. And now,
I was still not doing wave pool, because then I spent about 4 or 5 years doing that for my PhD, which was in 94.
Yeah.
So, and at that point, I still had not been exposed in any significant way. I'd taken wave theory in graduate school, but never really done any experimental work. It was a small little project on a technique using, it was a visualization technique, a sort of shadowgraphy technique to measure wave crests that one of my colleagues was working on. I was exposed briefly to that, but the experiments were done at another university and we were more analyzing the data. So I still wasn't, having my hands wet with waves even at that point. And so then it was only when I went after my PhD to work in France, where I stayed for about 10 years in Grenoble at the Grand Plaque Tournant Coriolis, which was the largest rotating tank in the world. Again, pursuing this stratified and rotating flows, where the stratification, which we use salt for, sort of mimics the change in temperature and pressure of the ocean as you go down, or the atmosphere as you go up. So you get this two-dimensionalization of all of the flows, where they're flat. The vortices are sort of like pancakes. We call them pancake vortices as a terminology. And so it was interesting to work in this Coriolis tank, where the largest one in the world. You could do the more, you could get closer with the physics to the reality of the ocean and the atmosphere. So it made sense. And it was during that time, between 94 and 2000 and so, when was exposed through this program of the European Union called Hydrolab. So Hydrolab was a program where each country in Europe might have several, this is when Europe was all coming together. And I remember when I went there, I was paid in francs and then later got paid in euros. So it was through the transition. And the program was designed for specific large-scale hydromechanical infrastructure, like the large rotating tank that I was working on. And the Coriolis tank is quite impressive. It's about 13, 14 meters in diameter and weighs, several hundred tons, kind of thing. It's a serious thing, and it rotates, can make a full revolution in about 20 seconds quite easily. And anyway, the point there was that we were part of this Hydrolab program that we got into. The Hydrolab program allowed us to share resources. So if, for example, a researcher in Italy wanted to come and use this large rotating tank, he'd be paid by the European Union to sponsor the travel and the fees and so on, because in Italy, they didn't have one of these tanks. But maybe in Italy or Spain or somewhere else, they have a wave flume that we don't have. And if some researchers from France wanted to go to that country and use their large wave flume, they would be paid. So it's sort of an exchange program that was sort of meant to build collaboration on the science. You generally needed 3 partners for a project. And we used to joke that the bigger the triangle, the bigger the money. So you kind of wanted to have a guy from Portugal working with a guy in Estonia with another guy in Athens. That would be a pretty big triangle in Europe, and kind of bring all those people together was considered a good thing, versus working with your next door neighbor wasn't considered to be as inviting for what the union wanted. They wanted to encourage people to mix throughout all of Europe. But the point of this is that program involved most of the countries had large wave flumes. So being part of the program and developing some of the instrumentation for the program, because by then I was a specialist in what we call DPIV, digital particle imaging velocimetry, which is used to be called PIV, particle imaging velocimetry, but it's a way of getting full field 2-component velocity data by seeding the flow with air or water with little particles and then firing laser sheets through and capturing sequential images and correlating them spatially to obtain the full velocity field over a plane. And nowadays, through a volume, we have 3D PIV now with 3 components in a volume, which I also developed a technique for. But back then, it was a big thing. So I would try to implement, for example, in the large limb wave flume in Barcelona, these laser imaging techniques to improve the capabilities of these giant hydraulic machines. And this is sort of considered necessary at the time because everyone was saying, well, the computer is going to take over. We don't need to build any more big wave tanks. We can do everything on the computer. And there was some thought, my thought was, well, why don't we modernize the measurement capabilities within the large tanks? That way they'd be more useful and provide data more akin to the type of data you get from a computer model, allowing more synergy between the two methods. That was my exposure to.
So that was when the wave exposure first began. So
this gets your feet wet with wave pools. You've had a really long road of academic research and then postdoc research that has sort of ultimately evolved into the marine space. And then I guess at the same time, this is starting to probably approach like the mid 2000s, 2010. Yeah. And Kelly Slater, who to those of you who don't know is the most dominant competitive surfer, probably just the best surfer ever to live. And Kelly's won probably, he's won probably what, like 10 world titles at that
he's
point.
Got 11 world titles.
Now he's got 11. And so at this point, when Adam still doesn't know who he is, he's, I guess, probably, 8, 9, 10 deep at that point. And he's on the world
7 deep. He was about 7 or 8 at that time.
Yeah. Okay. So he is, the most dominant surfer out there. He has obviously done well for himself, and he's on the World Surf League, or the WSL Tour, which is sort of the championship level tour equivalent to like the PGA Tour, if you're familiar with golfing. All the best surfers traveling around the world. And in general, just to give people some context, if you're not a surfer, the World Surf League is comprised of a number of stops that are all on different types of waves. And obviously these are naturally occurring waves from swell in the ocean. And a big part of the competitive piece is really the ability to adapt to the ocean's conditions. And it's not going to be the same, probably ever exactly repeatable wave from one set to another. So it's one, a piece of like surfing skill to win, but also two, really a piece of like ocean knowledge, familiarity with waves, and how to line yourself up in the right spot and how to capitalize on the sections of the waves. We could go on about that for a long time, but at this point, I guess, Adam, can you go into a little bit of like how you and Kelly, like you from this really academic lens, you were once a weekend warrior surfer, to Kelly, who's the best surfer to ever live, winning world titles, multiple years in a row. How do your worlds collide? I mean, tell us that story a little bit, and then what sort of became of it? Because it's really amazing that you guys intersected.
It was kind of interesting, and a little bit of, everything in life is you never know quite why it happens. There's always reasons. And so this point, I had sort of transitioned back to California. I'm working at USC, doing these ocean sonic boom experiments, and also working. I've always been a little bit interdisciplinary and tried to keep my connections with the marine biology section of that we have there at USC. So was doing some little projects with plankton motion and plankton and turbulence, and so I had some little plankton tanks going, or using lasers again to measure the motion of the plankton and the motion of the turbulence and look at that competition. And so would be regularly talking with my marine biology and oceanography colleagues that we had there. And someone one day mentioned something about a wave thing that someone had approached them, and I wasn't too sure. And I got an email from a guy named Larry Redikoff, who kind of said, I don't know what he said, but anyway, Larry had been a big guy in the department chair for many years and forth. And Larry also was very interested in oceanographic type applications of aerospace engineering, fluid mechanics. And he had been asked about his opinion on this wave project, which is a bit elusive. So I went to talk to Larry and said, oh yeah, look, he had talked to a guy named Tony Michaels, who was a professor there in marine biology, and they had been working, Tony had been in charge of working with the Wrigley Foundation Oceanographic Institute on Catalina Island that is owned by USC, where we have a sort of marine biology institute on the island. They take students over there, there's dorms over there. So one of the donors to this program was a guy named Bob McKnight, who was the CEO of Quicksilver. At the time, Kelly was sponsored by Quicksilver. So that was his main sponsor. And and this was before the WSL. Back then it was called the ASP.
Right.
And so either way, so Bob had been obviously talking with Kelly, who Kelly had this idea of trying to make this infinite, endless artificial wave that he was been dreaming about. And so Bob had reached out to his friends on Wrigley, on Catalina Island, who were, Tony Michaels and the marine biology guys. And they kind of, from what I understand, kind of said, well, we don't really, we know about fish and plankton and algae. We're not so sure about how to make a wave for you, but we have some friends over in engineering who might be able to help, and so they sort of contacted us, contacted Larry Redekop, who thought that I might be the right guy to do this, and sort of said, oh, you should talk to me. So he pointed, they pointed at Wrigley, who pointed at Tony, who pointed back at the marine biology, and I'd done some stuff with Tony. He pointed at Larry, and then Larry pointed at me. And so that's how it went. And, and the marine guys were all there, happy to contribute to anything relating to water quality and some other things. But when it comes to actually making the wave, it's an engineering feat. It's not a biological feat, it's an oceanographic feat. If you're a physical oceanographer, unfortunately, USC at the time did not have a physical oceanography department. As say, it used to have a couple of oceanographers, Tommy Dickey and Liba Washburn, in the geology department, but there was no oceanography department for physical oceanography. All of our oceanographic work was more biological sciences, pretty much. And any physical oceanography was done out of aerospace engineering. So that was sort of how we got connected. And then Kelly came, and at this point, I still hadn't heard the name yet, or maybe I had the name, but I didn't recognize it or know it. I just knew there was some project about making a wave. And next thing I know, Kelly comes over to see me in the lab, and he wants to discuss the wave. And he sort of explains, I'd been told a little bit about it before he showed up, at least that he wanted this annular ring, endless wave to run in a circle forever and ever. And and it sounded kind of cool. So and so we had a few conversations. He was passionate about it. You could tell right away that he kind of, he knew what he wanted. That's for sure. And that's the first part of any problem, right? If you don't know what you're trying to get, you're probably not going to get it.
Sure.
And he went away. Then I did some Googling and research on other technologies out there and who he was and all that kind of stuff. So that was kind of interesting, and it was exciting because it was super challenging. I was like, what he wanted, it was pretty clear. He just didn't want a wave. I mean, he wanted the wave. He wanted the perfect
wave. It's an amazing story because, like, when you talk to a surfer, I mean, like I surf like recreationally. I love like getting in the water, and when you are talking to the best surfer to ever live, I mean, Kelly's literally surfed everywhere in the world. He has chased the best, like, naturally occurring waves everywhere on the planet. And I mean, he has experience in probably more than anyone else ever in the ocean in terms of like competitive and also the free surfing world. And, he comes to you and he's like, well, I've already surfed all the perfect waves of the world, but like, I want something that's even better. And for people who don't surf, Like if you're just a Joe Schmo, kook out there, like if you get a 10 to 30 second ride, you're pretty stoked. Like that's a pretty fun wave. Like beyond that, like there are places in the world where you can surf and like get barreled for more than 30 seconds or a minute, but it's hard to come upon those days and those waves when conditions line up. And so I think for Kelly, like the way that I sort of understand it is that his goal was to basically at the push of a button be able to simulate a perfect, like minute long wave or more initially, I guess was his dream, that simulates like all types of conditions. It's powerful. You can get barreled, which is when you get tucked under the lip of the wave. It's like sort of the ultimate feat when you're surfing, like every surfer chases that. And then also have performance sections where you can do these big airs and tricks on the wave, right? So like what was that like when he framed that to you? Like when he described what he wanted out of the wave initially, what did he say?
Well, initially he wanted the barrel and all of these other things you just talked about, which is obviously what we eventually kind of put together. But in the very beginning, it was all about the barrel. It was like the most important thing probably to most surfers is getting barrel. I mean, it's kind of like the ice. I don't know. It's the best. I don't know. It's kind of strange because, when you're in the barrel, you're not even visible if you're really there. No one can see you. Judges don't know what's going on, but the point is getting barrel is sort of the ultimate experience in surfing. And he wanted a wave. His basic thing was he wanted a wave that you could get properly barreled in. Now, he didn't come and say, I want a 6 foot, this, that, no, he just said, I want a wave you can get barrel in. So I looked at him and, okay, I got to make a wave that this guy can fit inside the barrel. That was kind of it. And he wanted it to be endless, not a minute long. He wanted it to be infinitely long. So this wave in his mind was in this donut-shaped tank, and the wave would just keep going around the donut forever and ever and ever until you got too tired to surf it anymore. So that was sort of the very beginning, and that was what the whole energy was. Let's make the barrel. Now there was talk about some other things, but that was secondary because people already had artificial waves, like at Disneyland and so on, that were existing, but they didn't barrel, but you could still ride them, consider that wouldn't be too hard. But to make a barrel, and the barrel had to be of the correct shape, size, thickness of the lip that's throwing over, and the slope and curvature of the surface had to be such that it was surfable. It had to be this particularities about the barrel that make it possible to get inside the tube and to find an edge and hold in there. So that was a hard part for me to understand because I'd never been really barreled in my life, maybe for a second before the wave just pummeled me.
Yeah.
And, so I didn't really know what it was like to actually ride a barrel.
Everyone's been there.
Yeah. I had to learn what that meant and what he really wanted. And that was a bit of a back and forth to kind of comprehend what he was really looking for.
Yeah. Okay, cool. I mean, it's really interesting to see how it ultimately developed. And I'm sure there was many different designs and iterations, obviously, that followed. I mean, it's cool to hear the initial idea and how it was communicated to you from the best surfer to ever live and still one of the best surfers in the world, in his pursuit to literally just at the push of a button, basically like in his backyard, have the ability to ride a perfect wave. Like, even though he has, ridden perfect waves all around the world his whole life. So I think that's amazing. And so from there, right, you guys kind of kick off this partnership. He frames the idea. It's this huge idea. You're like excited about it. It's a huge challenge. You don't even know if it's probably that doable at this point. I would assume. That's right. Like, is this even possible?
Yeah.
What happens next? Like, where do you,
well, then I reach out to my network. I bring in all the smart guys I know from academia who know much more about waves than me, and I put them all in a room together with Kelly. And then we just go over it. Kelly stands up there on the whiteboard, explains to the whole group of smart people, hey, this is kind of what he wants. And I chime in and say, yeah, this is what we thought about. And I've done some little research. I have some ideas that maybe we could do it like this. And we all talk it over. And, and even in the room, there was not a full agreement that it was actually possible. At least by the methods that we had proposed, there were some skeptical that maybe the wave would not be properly surfable because of a sort of translation of the coordinate system to what we were theorizing, versus what would be in reality in the ocean. In other words, there was questions about, would this, quotes, artificial wave actually mimic correctly a real wave in the ocean, or would it be something totally different, which may be or may not be better or worse? But so that was sort of a little bit of a thing there, just to convince ourselves that, yeah, this would mimic exactly the type of wave that occurs in the ocean in the most perfect conditions. We have to be sure of that. Otherwise, you could develop a wave that might look like it's the correct thing, but wouldn't actually be surfable.
Right. From the time that you meet Kelly and you get this round table in the room with the other scientists, your colleagues, your network, and Kelly, how many years is it then to the first surfable prototype?
Oh, wow. So that would have been when we met Kelly, 2006. By 2007, I'm sure we had the round table. I'd have to look back at the dates. Might have even been the same year. The round table, from the first meeting to the round table, was probably just a few months to do some little background research and maybe just kind of get some ideas going. I think we ran some tests in a water channel just to kind of see if our ideas were valid. And then, so let's say 2007 to where we're really kicking off. We've kind of got an idea. We're going to start work on this. Okay. Yeah. And Kelly would have to get some money from some of his partners or something to give to the university to kind of say, hey, guys, can you put some time into this? So 2007, we kick it off. And our wave was it December 2015 that we debuted the wave. So what is that? So, it's almost 10 years.
Yeah. I mean, I remember
9 years solid.
Yeah. And I remember crystal clear. And I remember how impressed I was of how much of a secret this was kept as well. I mean, it was totally under wraps. No one knew about it. I mean, I was young at the time, but I was still enamored with surfing and the ASP, WSL. I loved following all the events. And personally, I had not heard anything about it. I mean, I was up in Vermont, but I still loved surfing and was pretty tied into the channels. And, when I saw that video for the first time, I remember just being so blown away by the fact that was created in a wave pool. You think back to your experiences at a water park as a little kid where you're in a sloppy wave pool, everyone's on boogie, they're just crumbling. It looks like wind swell. It's crumbling waves that aren't really rideable. And then you fast forward to 2015, this video gets released of Kelly just so stoked when he sees the first wave being pumped out. I'm sure you were there, obviously. And you see him ride a minute long clean face with 2 barrel sections in it. It's just it was I couldn't even believe it was real. It was amazing. I'm sure that millions of other surfers felt the same way. And in that moment, it's pretty amazing to think that you literally, I mean, that changed the trajectory of the future of surfing and the accessibility of surfing, right from that second that video came out, which is just does that feel pretty cool to have played a key role?
Yeah, I mean, it's definitely a good thing. That I think you're right there, that the momentum towards artificial waves has really improved, and that video probably helped that. And as we know now, there's multiple companies around the world implementing and constructing waves that are completely rideable and have barrels on them. So it probably played a good part in that, in making people realize, hey, you can do this and have it barrel. You can actually do this. It's not that hard. And I think we contributed a bit to that momentum for sure.
Definitely. I mean, I remember thinking immediately, I was like, this is going to change the game. Like it does not replace surfing in the ocean by any means or competing in the ocean, because the whole other element that I personally enjoy, and I know that professional surfers definitely enjoy, is having the ability to, compete in changing conditions, because that's a huge piece of the competitive landscape and
Mm-hmm.
surfing landscape. But it just opens up a new door. I mean, I think it just gives more people the ability to get in the water, to be familiar with surfing. It grows the sport, and what grows the sport is good for the sport, in my opinion, and good for the ocean overall. So I think it's just it wasn't a substitute, but it changed the game, certainly.
Yeah, and we saw it evolve. We in the surf ranch, it's what we call the location in Lemoore where we built this first wave. We built it. We proved that it would work as a prototype. We tore it apart. We rebuilt the reef, make it different, make it barrel differently. We tore that apart again the second time, and then rebuilt everything in a bit more seriously. Not still prototype-ish, but a bit more robust. That changed. What we have now, as you can see from the more recent videos, is it no longer is just one complete barrel. We found that surfers, when you talk to the competitive guys and they want to experience some open face and some barrel, so what we have now, and then they want an air section. So right now the wave has 3 or 4 different sections that are distinctly different based on the bathymetry and the profile of the hydrofoil we use to generate the wave. But it's evolved already, in that, okay, the barrel was great, but what do people really want? Well, okay, they can only get so much barrel, which is amazing, but they still want a piece of barrel, but they don't mind a big face to carve up.
Yeah, sure. And so I guess just to provide some more context, like, you spoke a moment ago about the reef and bathymetry, and like, there's obviously a lot of different components that went into designing the wave and optimizing the wave. And when you look at waves around the world, there are thousands of different waves that have different shapes, different sizes. They barrel, they might be long, rolling, open faces for people to just do huge carves on, or big airs. And that all really comes down to the bathymetry and the shape of the bottom contours at that spot, right? Like the shape of the reef is what ultimately dictates what the wave looks like and the shape of the wave. So for you guys, did you sort of study a lot of the like pipeline, some of the key surf breaks, lower trestles around the world, and what that bathymetry looked like, and then you tried to model it into a pool? Or did you just sort of like experiment in the lab and come up with that on your own?
Well, we did look at any bathymetry we could get from a known break. We would look at it. And what we found was that it was difficult to try to mimic this ocean bathymetry, simply because in the ocean, the wave has a lot more room to propagate, while in a man-made wave pool, you limited in the size. So you didn't really have the type of space to allow the wave to shoal and break in the same manner as it does. But we were able to learn some features of what helps to like pipe, for example, but to actual mimic that exact bathymetry wouldn't be practical. This wouldn't be practical from an engineering point of view. And so we were inspired by that, but we ended up having to do our own experimentation. We built a 15:1 scale model prototype after we left the university. We started the company. We rented a warehouse in Culver City and built the prototype model. Sort of by 2008, 2009, we were working heavily in the prototype. And so it was experimentation. We had our master technician, Ken Lucas. We'd build all these reefs out of wood and acrylic and try a different reef, every week we'd be tearing it apart. Let's try a different shape here. And we're really doing lab measurements, making velocity measurements and wave height measurements in the lab. by this time it was a 15-to-1, so the wave was about 6 inches high. So we were, making 6-inch waves that we thought we could scale to the full size, and that was a bit of the fun time, the real lab research. And then later we started to bring in the computing and started to do some computational fluid mechanics to simulate other aspects that we couldn't quite get from the lab measurements. But we were then making a consistent, very good 6-inch wave in the lab that we believe we could scale. Now we had to convince our partners in the company and other people, investors, that our little 6-inch wave would work if you made it at 6 feet, and that was kind of the leap of faith that they had enough confidence in us that they were willing to finance the building of the prototype, which, it's a big machine and it's expensive and it's, millions of dollars. So that was a big moment when we started construction there in 2013.
Yeah. No, I mean, it's amazing. I mean, the fact that you were able to instill enough trust in your models and your scale prototypes to say, all right, let's go dig the hole and build the real reef and design the hydrofoil and that mechanism to actually generate the wave. And I mean, it's obviously worked out great. So you guys killed it. And what do you think? I mean,
science project to an engineering feat. So there was that transition where he's all science. He's in the labs, prototypes, scale modeling, computing, measurements and things. And then it turns from there into now it's an engineering feat of how do you actually build this? Now you think you know what you want to build, you still got to build it.
Right. Serial number one, too.
A good engineer, our chief engineer, Jeff Bennett, and he was instrumental in getting it built on time and a little over budget.
I guess that's how it always is, right? You couldn't assume serial number one was going to be under budget. And so, like, from your perspective, I mean, being so deeply involved on the technical side with the experimentation, ultimately the build, the implementation, seeing that first wave get ridden in 2015, all the way through to actually hosting a WSL event at the ranch, which was really cool. I mean, that was awesome. I know that'll probably be a thing in the future as well when we get back.
They're going to have another WSL event this year.
Great. Yeah. And so, like, where do you think, from your perspective, maybe not directly involved with the WSL tour, but like in general for the future of surfing, what do you think wave pools are gonna look like down the line, and how does that influence both recreational surfing and also, the world tour and like the highest level of competitive surfing, whether it be on the WSL or in the Olympics?
Yeah, well, Nevin, that's a good question there, because I think everybody would love to know the answer. Everyone in the industry, I mean, that's kind of the thing. So there's two paths here that I think both paths have to be occupied. One is it's a fun thing to do. A lot of people would love to try surfing. They don't live near the ocean, for example, or they're just afraid of sharks, or for a variety of reasons. And here you have the possibility to stoke out, thousands of people if you can build a wave pool which has sufficient throughput. It's sort of like imagine a Waikiki, where you have, hundreds of surfers just out there on soft tops banging into each other, and they're all having blast, right? So there's a whole avenue for that, that's great, and that's going to be a big part of this is providing that experience to a large number of people. Now, there are surfers who say that's not good because now these amateurs, artificial wave guys, are now going to want to go in the ocean and fill up the lineup. And so there's a whole group of people who don't like it for that reason. But then the counter argument is, well, no, they're going to be in these artificial ones, so there will be less people in the lineup. So, either way you go. But if you grow the sport, ultimately, these guys are going to want to have a go in the real ocean.
Yeah.
They will. Yeah. So you are growing the sport, you're increasing the number of surfers, and it will have an effect on the lineup. Now, but if you have enough of these, there'll be enough of them to, so that there's that aspect. And then there's a part of, a competition wave, a real barreling wave, which is too heavy, too dangerous for an amateur. So you don't have the same kind of throughput, and you're going to have accomplished surfers who all want to give it a go, but it's difficult to do that for a large number of people at the same time. So I think the holy grail is going to be providing both of those experiences in the same wave pool environment, where you can actually host a competition, but at the same time, on the day after, you could stoke out 1,000 people on soft tops in that same pool.
Right. So that's the thing. And I'm guessing that the reason for that from a business perspective, right, and investor perspective is it true to assume that the cost per wave is significantly higher when you're going for like a high performance barreling wave versus pushing out like a higher volume of a small, like waist high, just rolling, peeling left that everyone can go out and get on a soft top?
Yes. So, well, from an energy point of view, that is true. So completely clear that if you're just worried about the energy, it's related probably to the cube of the wave height and got other parameters in there, but the energy is going up with the wave height, but then the energy use per wave is not really your biggest problem. Sure, it's nice to have a more energy efficient system, but usually the reason is that the infrastructure, the capital investment to put in a mechanical or whatever type of system it is that is capable of producing a wave of that size and power is much more expensive than the mechanism you might need to implement just to create a smaller kind of whitewatery 3-foot surfable but not barreling wave. So your initial investment is a lot higher if you're trying to design a system that can create these large waves. So that's a bit of a hurdle there. And if you start getting much bigger than the largest ones out there, the costs can get high very quickly.
Yeah. And so from your perspective then, I mean, you're obviously implementing the technology. Do you see a commercially viable path where, higher level wave pools? I know people are already really like almost franchising them in certain parts of the world, like where there's a commercially viable wave pool that's quickly profitable from time of build to, cost per wave to however much someone's going to realistically pay to actually go and surf it.
Absolutely. I mean, it's proven out there. It's there. And time will tell how long these pools remain in business, what the demand is, how many more are built. But I think all of the players in the industry are now kind of honing in on the sort of sweet spot of commercial viability. And that's going to develop the models. There's a lot to be said about the organization of the surfers. How do you sort of do this in a safe manner, and how can you get the most surfing experiences out of whatever waves you have? But I think it's a little bit different from. It's not going to be. I don't think it's going to be like a ski resort where you buy a ticket for the day. It's not. It's going to have to be an hourly kind of experience to bring the price to that level for sort of the general population.
Right, which makes sense. I mean, that's what most surfers, you want to get a session in. You
get a session
for an hour, 2 hours, even like going to a skate park. I mean, that's what it comes. So, no, I think that's great, and it's cool to see that the technology is becoming more scalable. And so, is that what's next on the plate for Wave Co or for KS Wave Co? I guess it's now called Wave Co, right?
Yeah, it's WSL Wave Co, I think his official name, but we still keep the name Kelly Slater Wave Company.
Yep.
And so we're a current project in Palm Springs. That's going forward. It will be similar but different to what we have in Lemoore. And I think from that point of view, the technology is rudimentarily the same. with obviously improvements and things. But I think if you look a little bit further down the road, especially if the market evolves, I think we'll probably have to be a bit more creative about addressing the broader market, needs, and probably introduce a new technology to satisfy that demand.
Yeah. No, it's amazing. I mean, one day I hope I can get out there and get a session in at the pool. That'd be pretty cool. So I know that we're sort of coming up on time here, but I have two more questions for you that I think sort of bring everything together, right? I mean, we've talked about your journey, the wave pool, the evolution of wave pools, becoming more of a viable business model, how that influences surfing. And I think that that's really one of the more interesting things here is like on this podcast, our goal is making the ocean more relevant in many ways to the general public, right? I mean, bringing some light to technology and initiatives that are shaping the future of our lives. And we all do depend on the ocean. So my first question, sort of less related to the wave pool specifically, is, what do you see from your point of view as like, why it's so important that we focus on the ocean and conservation and bringing light to technology that's like, enabling us to preserve it?
Yeah. Well, I mean, it's pretty clear. I like your concept, the 70%. I mean, it's a great kind of name, and most of us interact with the coastal ocean. Some of us go out on boats, but I think generally the majority of the population is happy to be on the seashore. It's where the ocean meets the land. It's the most interesting and diverse and dynamic location in the ocean, where you have waves crashing on rocks or rolling up sand. You have all of the coastal ecosystems and nutrients and things around the coastal zone. And this is the area where most of us interact. And that's where you have surfing waves in these areas. And so there's a lot to be said about, surfers tend to respect the ocean a lot. They're concerned about it. And so maybe by increasing the people who surf, building the sport, we might end up with more people who at least will appreciate the ocean a lot more when they are there, just having been exposed to a little surfing in an artificial pool. But that's that's sort of something that we will have to see how that works out. And on a sort of side parallel note, that some of these wave pools like ours, so we've used our wave pool in collaboration with the Scripps Institute of Oceanography in San Diego, UCSD, to look at modeling and measuring the effect of wind on waves. So we have a controlled environment in Lemoore where we can generate the same wave again and then monitor the wind and get data that is very difficult to get in the ocean. So there's that synergy in that direction. But it really is, there's things that are important in energy is always a big thing. And just for an example of these type of interactions of surf and energy, there are devices that extract tidal energy or wave energy out in the ocean that have been implemented by countries like in Portugal and Scotland and other countries are doing this. The US has some as well. And so if you place these wave energy capture devices off the shore, you capture the energy of the waves and send it back to land through some undersea cable to power the city. You have to be aware that by doing that, you're removing the energy from the surf. And now those waves that were going to show up on a beach somewhere and people were going to surf them are not going to show up. So you do have things like this that people are maybe not so aware of, that they think, oh, great, free energy from the ocean. But now you're taking that energy out of the waves and you're going to potentially destroy the swell for some surface somewhere. And so it's coupled like that. And the same thing goes to coastal developments where you build a jetty or you armor a cliff. And so we have to be very careful about how we interact with this border. between the land and the ocean and the coastal areas, especially if we're concerned about things like good surf and erosion and other issues that are relevant to the coastal environment, coastal
Yeah.
side.
I mean, I think you answered my question, and then you also answered my next question without me asking it. So that was great. I mean, I actually haven't heard it framed in that same way. In terms of the boundaries and the intersections of the different technology that is really becoming more prevalent with regard to like renewable energy, and then how that impacts our coastlines and recreational sports. So I think that's great. And I think that the most relatable thing that you said in that description was, and I guess to backtrack for a second, a lot of people look at the ocean and what, just like with this documentary that just came out called Seaspiracy, and then ocean and pollution and overfishing, everyone thinks about those issues, right? In terms of how do we create technology that's going to eliminate pollution in the ocean or stop overfishing, right? But what a lot of people might look at with the wave pool is that it's a fun thing. Like it's this cool thing for professional surfers. You got to pay to go and use it. It grows a sport. But what I think a lot of people don't necessarily think about right away is that the technology that you're developing and other companies are developing with wave pools to grow the sport ultimately will lead to preserving our ocean, because of the exact point you made, where no matter what your political views are or your thoughts are on climate change or any other naturally occurring effects, if you are a surfer, if your livelihood or recreation happiness relies on the ocean to any capacity, you're going to want to preserve it and save it. And you immediately have a relationship there that runs pretty deep. And so I think that what's cool is that you're not only progressing a sport with wave pools and making a sport more accessible, but in turn, you're creating a community of people who actually care about the ocean and care about preserving it, and will ultimately, improve the accessibility and demand for technology that's gonna take plastic out of the ocean, or try and stop overfishing and allow us to continue to do what we love and live on the planet. So I think that's sort of the double-edged sword here that a lot of people might not recognize at first, that you framed very well. So I personally relate to that a lot.
Yeah, and that's part of the effort behind the WSL Pure program, which is has one of the initiatives is the plastics and so on. And I really think, I think for me personally, my biggest issue are two you mentioned. They're pollution and overfishing. Those are the two that really get me, and I hate it. The overfishing, especially spearfishing in particular, and I get it. People have to eat, but there's better ways maybe to do that, and they don't realize that if they overfish, then maybe they'll eat, but their kids won't eat in 10 years because there'll be no more fish. So
Yeah.
But it's hard to tell a guy he can't go and get a fish because he's hungry.
Sure.
It's a difficult one, very difficult problems, and they need smart solutions.
Yeah, absolutely. Well, I think that you're by developing such amazing technology for surfing, I mean, ultimately all these efforts and worlds collide, and it will lead to progression on the sport level, and also progression on our efforts to preserve and save the ocean moving forward. So I think it's an amazing story. I think it's amazing technology, and I cannot wait to see where it goes. And one day, Adam, I hope I can get in the wave pool at the ranch.
And we'll get you there. We'll get you there.
Springs. We'll get out there, and we'll have to have a session. That'll be a good time.
Well, it's always a pleasure talking to you.
Thank you so much again for spending some time with me today. It was awesome, and one day we'll have to do a follow-up episode in person.
Excellent. Well, Nevin, thanks again for having me. It's a real pleasure, and all the best going forward here.
Thanks again to Adam for joining me today on the show to discuss wave pools and how they will continue to host professional surfers and surfing enthusiasts as Wave Co expands their operation into multiple locations globally. If you are interested in learning more, you can see photos and videos of the surf ranch at kswaveco.com, including the famed video of Kelly Slater viewing and riding the pool's first waves. In addition, we encourage you to check out the WSL Pure program and join World Surf League in their efforts to promote ocean conservation and awareness of the importance of our oceans in our daily lives. As always, we are looking for new ways to bring together those with an interest in our blue planet. Tune in again in 2 weeks to hear more from inspiring entrepreneurs, technologists, and activists who are building the blue vision for the future.